Early adoption of technology is a point of differentiation between being a pioneer and a must have for solution providers. Autonomous mobile robot technology is no different in this case, and solution providers are rapidly or rigorously pursuing this technology in order to gain their market leadership. Mobile robots can operate 24/7 in warehouse or surveillance industry or surveillance applications in order to provide reliable and a continuous output for these systems. The age old technology of robotic arms is evolving as well in order to give better dexterity and reliability in industrial solutions while also improving their real time decision making skill. Both these technologies require an accurate vision system in order to cater to the complex applications they service, and choosing the right imager is the key to building a robust system for the different applications. Hi, this is Yogesh, and in today's edition of Unraveling Computer Vision and Edge AI for Real World, I shall be talking about choosing the right imaging system for the AMR or the autonomous mobile robots and the robotic arm applications. Cameras are the most critical sensor in AMR and robotic systems with multiple imaging needs. For example, in AMR, the camera might be used for direction or vision and also for recording purposes, as well as multi-camera systems for complete surrounding awareness. While in robotic arms, the major decision making is done based on the detection information that we obtain from the camera vision. Both these systems being deployed in moving environments where either the target is moving or the system is itself moving. High response rate or high frame rate from the camera becomes a critical factor here while designing a camera system for these applications. And the high frame rate from the camera needs to be complemented with a high speed data interface that needs to be supported by the camera in order to transfer the data to the processing system. Having said that, fast frame rates can help us capture these moving objects. Our images still need to be devoid of motion blur for the detection systems to be reliable. And the technique of low exposure time or fast shutter speeds helps us here. The idea is during the low exposure time, the object would not have moved much. Therefore, we would have captured the image reliably, and detection process or understanding process of that image shall be reliable. So to summarize, fast frame rates and low exposure times are the key factors when it comes to choosing a right image sensor or a right imaging system for AMR and robotic arm application. Camera like Steadicam, which has a low exposure time capability and a high frame rate capability, would be an optimal solution for these applications. The Steadicam 20 is a IP67 HDR GMSL camera with capabilities of data transmission up to 15 meters using the coaxial cable. Thereby, it can cater to the AMR and the robotic arm applications in different industrial environments. Another usual requirement when it comes to the autonomous mobile robot systems is the need for multi-camera imaging. These systems usually have more than one camera working in sync with each other so that the system can be completely aware of its surroundings, and the decisions are taken after processing the images from these multiple cameras. And synchronization is required with these multi-camera systems so that the system sees the same image from different angles at the same time. And usually a trigger signal is used to achieve this synchronization functionality. So when selecting an image sensor for this system, one needs to be aware if it has a trigger functionality. Therefore, we can build a reliable AMR system. So we discussed about choosing a right image sensor for our application. Now the next step would be adding a right image signal processor to our sensor so that we achieve a right imaging solution for our AMR system. So why do we need an ISP here? Image sensors usually give out images in raw format, and they do require corrections when the environment varies randomly. Different image processing corrections and the algorithms cannot be done in the sensor itself, so we require a controller, which is a ISP or the image signal processor, that offloads all these processes and works in sync with our image sensor in order to give out our best image quality. The advantage of having an ISP is it offloads all these algorithms or the processing from the processing CPU and keeps them in the ISP so that the CPU is actually free for our end detection or image vision application. So having discussed the ISP and the sensor needs, the next design consideration would be the optics. So selecting a lens is mostly dependent on the field of view that we require and the sharpness parameters like the focus and the depth of field. While FOV is determined by how much our target object covers a frame of one particular frame, which in turn determines the detection and the understanding capabilities of the system. The depth of field and the focus parameters are important because only a sharp image can be reliably detected by the system. So looking into all these comprehensive parameters while designing your imaging solution accelerates your product development and helps you reach the market faster. This is Yogesh signing off from this edition of Unraveling Computer Vision and Edge AI for Real World. Bye.